Welcome to part 3 on logarithms and graphs. In this video, we need to use transformations that we learned to graph 2 plus log base 10 of x. Now remember that if you add a number or subtract a number from a function on the outside, not the inside, but the outside, then that will either shift your function up or down. So since 2 is a positive number, it will shift the function up 2 units. And so we know that a standard graph of this function, this log base 10 of x, would have a fairly sharp curve at first. It will go through 1, and then it has a very shallow increase as we move to the right. So I can use my coordinates that I normally would know that log base 10 of x has. And so the only really obvious one it has is that it approaches the vertical asymptote at x equals 0, and it crosses at the point 1, 0. And if I'm shifting this logarithm up 2, then I can count up 1, 2, and I can recreate my curve, but at the point 1, 2. So I go from 0 to 2. And sketching that, it would look something like this. So you can see that the function has been transformed up 2 units. Now let's take a look at g of x equals negative log base 10 of x minus 1. Since the x minus 1 exists inside the logarithm, we need to figure out which direction it will shift. We know that inside a function is the opposite direction, so this will shift to the right 1 unit. And since the function overall has a negative in front of it, we know that the function will flip about the x-axis. So I'm going to give a general sketch of the original function, log base 10 of x, that crosses at the point 1, 0. It also approaches the vertical axis, and it increases slowly to the right. I now need to shift my function to the right 1 unit. So now instead of it being at 1, 0, it will be at 2, 0. And my vertical asymptote will now exist at 1 instead of 0. And then I'm going to flip my function about the x-axis. So my final function will still cross at 2, 0. But instead of the function approaching negative infinity, as I get closer and closer to the vertical asymptote, it will approach positive infinity. So this is the transformation of log base 10 of x. And I'll go ahead and erase these other two functions.